Okay, so we continue with the next unit about point patterns. You will check in Moodle where's this material is uploaded. Okay, so it's basically the unit. I need to rearrange a little bit the names of the units, but this is unit 1, unit 2 is probability theory, unit 3 is statistical test, unit 4 correlation and least square, and then we have unit 5 and 6 just to conclude the course. Okay, so unit 5 is point pattern and kernel density, and unit 6 interpolation method. So the new component or the novelty that we add from here until the end of the course is basically the spatial component of the data. So far, we have worked with exercises which basically comprise a pure statistical concept. Sometimes we use spatial data with coordinates, but it was not really required to understand and to the different techniques. From now in advance, we focus specifically in the spatial component. Yeah. So, according to the GIS dictionary, spatial statistics is the field of study concerning statistical methods that use space and spatial relationship, like distance, area, volume, length, height, orientation, centrality, and other spatial characteristics of the data. Yeah, so everything involving a spatial component and their relationship is under the field of spatial statistics, and we deal with directly in the direct computation of mathematical computations of this relationship is the matter of spatial statistics. Before we start going through the different type of analysis, we also need to cover the types of spatial data. We have event, fixed location, and exhaustive data. And some of the techniques are more appropriate to each of these type of data. So with this event data is something that has occurred in an area. The unique attribute, or at least the most important attribute, is the location where this is happening, and although it might have some associated attribute data, continuous or discrete. Examples are the crimes in a city, accidents, the trees, or the position of animals, yeah, or volcano. So for those events, the most important is where these things are happening, more than other characteristics uh, related to the events themselves. They are analyzed through spatial point patterns. Yeah. Second type of data are fixed location. Yeah. Normally, the spatial arrangement, are the result of a sample survey. One or more variables are sampled at a number of fixed locations, and what is more important, the type of sampling might be systematic or random, and the most important is the variable they measure. So normally you can assimilate this is the type of data which is collected by a sensor. You have a sensor of temperature, you have a sensor of pollution, or a sensor of they measure a specific nutrient in the soil, and so weather stations. So when there is a weather station, it's not really very important if it is located in the roof of NAST or in the roof of a Bani hotel. Yeah, to basically represent the weather conditions or the weather parameters of Binduk. What is important is actually first, of course, that is in Binduk, and then the continuous measurement of this data, what means moist, humidity, wind, temperature, and so on, so on. But is normally part of a design sample survey. Okay. And then the last one is exhaustive, which that one can be assimilated with raster data, contains a value for the variable of interest for the entire study area. So as is a grid, as the raster does, can be continuous or discrete. So the type of data, remember the R tutorial, yeah, it's also it can fit into this type of data. Examples include DEMs, aerial photos, or sometimes even some census data after interpolated. Area are considered exhaustive spatial data that is aggregated to area units. For example, census data, which is assimilated to or is recorded in enumeration area units. Remember also from demographics. That's why you find also that it can be continuous or discrete and can be represented by a polygonal thematic map or a raster. But what is more important is that the whole area is covered. Yeah. Okay. So before we continue with the analysis themselves, we have an exercise here during the class, and in this exercise you will need to find more examples of each data type. Okay, more examples for the event data, for the fixed location, and for the exhaustive data. Okay, and then we continue. We submit your answers, and we continue with the next one with the point pattern and kernel density examples. Thank you.